When using physics method number 1, first thing you need to do is identify the junctions. And a junction are the places where the current could split. So these are the junctions, and a path or wire is connecting those. I have 3 different paths to take. I have this left side, middle, and right side. So at this point, you establish a current that flows through each of them. It does not matter whether you pick the correct direction or not. Now, looking at this, I probably have a pretty good idea of the direction that the current is going to flow through each of these paths, but I'm just going to pretend I don't know that, and I'm just going to generically start from here in this left path. I'm going to assume that the current is flowing clockwise. In the middle, I'm just going to assume that it's flowing up. And on the right side, I'm going to assume it goes counterclockwise. I could have picked any of them to be flowing in the other direction. Matter of fact, my gut would be that this one right here is going down, but I just wanted to go through an example where it's going opposite the direction that you pick, and it's okay. Now, in order to come up with my equations, I have 3 unknowns, so I need 3 equations. So one of my equations has to be using the junction rule. Whatever flows in, flows out. So I can either pick the bottom junction or the top junction. I have the same 3 currents involved, so let's just start with the top junction right here. I have what's flowing in, IA plus IB plus IC, is equal to what's flowing out, 0. Now, obviously, one of these has to be negative, or all of them are 0. One of those are my 2 choices, but since they're not all 0, one of these has to be a negative number, and that will come out in the math. To get the other 2, I'm using the loop rule, or voltage rule. Now, I have 3 different loops. Now, if we look at the basic structure here, I have this left loop, I have this right loop, and then I have the whole loop. I only need to pick 2 of them in order to be able to solve it. I don't want to use all 3 because they're not 3 independent equations. Only 2 of them are independent. In other words, if I have 2 of them, I can derive the 3rd one. So to come up with it, I pick a starting point, which is also my end point for the loop rule, because the sum of the voltages around the loop back to where you started is 0. So I am going to start here, and just my own personal preference, I like the first number to be positive, and so I'm going to go this way. So I'm going to do the left loop here. So I start with the left loop, I go across that. I'm going from the negative side to the positive side. And so it is positive 8, I gain potential. I'm going across here. Now when I go across a resistor in the direction of current, if you think about that current, water current, liquid current flows downhill, and if you're going with the current, you're going to a lower potential energy. Well, the analogy holds here that if I'm going with the current, I go to a lower electric potential. And so minus 3IA and then I'm going down the middle here. I'm going against the current. And again, if you're going against the current, you're going uphill. So I gain, so plus 4IB. I'm going across this battery here in the direction of from a negative to the positive. So I gain 30. And then I go across the 6 ohm resistor in the direction of the current that I picked. So 6 minus 6IA is equal to 0. I can simplify this down. I have 8 and 30, so I have 38. And put a little check mark there just to make sure I cover everything. I have 2 IAs. I'm combining like terms, so that's minus 9IA. And then I'm left with plus 4IB equals 0. Now you might be able to keep this straight in your head without doing the check marks, and that's fine. In something like this, yes, it is quite easily done. However, some of you are more organized than others. I'm going to do the right loop, and I'm going to start here. I could start anywhere, and I can go in either direction, but I'm going to start here, and I'm going to go in that direction for my voltage loop. It does not have to be in the same direction as the current. Absolutely does not. That's just the way I'm picking it. So I go across this battery from the negative to the positive side, so that's 17. I'm going across this 9 ohm resistor in the direction of that current, so minus 9IC. Then I'm going down here against the current that I selected, so that's plus 4IB plus 30 equals 0. The only thing I can combine here are my constants, so I have 47 plus 4IB minus 9IC is equal to 0. Why did I reverse the order here? Because alphabetically B comes before C. It's not necessary, just, again, another remnant of childhood trauma. If I wanted to do the whole equation, and again, I don't need to, if I do the whole equation, I'm going to just start here and work my way around. So I have 8 minus 3IA plus 9IC, because I'm going against the current I established, minus 17, because I'm going from positive to negative, minus 6IA equals 0. That would be the whole thing right here. I can combine it into negative 9 minus 9IA plus 9IC equals 0. Notice that if I take, plus 9IC, notice if I take that and subtract this equation from it, I get that equation. 38 minus 47 is negative 9. Negative 9IA is just negative 9IA. 4IB minus 4IB is 0. And then 0 minus negative 9IC is positive 9IC. So notice that I almost made a careless error there I made that negative, even though it's clearly a positive right there. There are so many places doing this to make a careless error. So please be very careful. But this is not independent of these because I can derive that from this. But this, and this are the three equations I am going to be using.